What is the density of Freon 11, CFCl3, at 120 degrees Celsius and 1140 torr? A. 1.59 times 10 to the 4th grams per liter. B. 20.9 grams per liter. C. 6.39 grams per liter. D. 22.4 grams per liter. This problem uses a modified form of the ideal gas law. PV equals nRT, where P is pressure, V is volume, N is the number of moles of gas, R is the ideal gas constant, and T is temperature in Kelvin. The problem appears deceiving because it is asking for density, which is nowhere in the equation. However, we may replace N, the number of moles of gas in the ideal gas law, with the expression m divided by the mW, where m represents the mass of the gas and mW represents the molecular weight of the gas. We know that density is equal to mass over volume, so we will use algebra to rearrange the equation of the ideal gas law to solve for m over v. After rearrangement, we get density equals pressure times molecular weight over RT. Now we extract all of the given information from the problem that we will substitute into the equation. We see that the pressure is 1140 torrs and the temperature is 120 degrees Celsius. The ideal gas constant is always equal to 0.0821 liter atmosphere per mole Kelvin. We are given the molecular formula of Freon 11, from which we can calculate the molecular weight by adding the atomic masses for all of the elements in the compound. 12.01 for carbon, 19.00 for fluorine, and 3 times 35.45 for chlorine, for a total of 137.36 grams per mole. Next, we must make sure that the units of the given pressure and temperature match those that are in the ideal gas constant, namely atmospheres and Kelvin. We will need to convert both pressure and temperature. Temperature can be converted from Celsius to Kelvin by adding 273 to the temperature in Celsius, for a total of 393 Kelvin. To convert the pressure from torrs to atmospheres, we must use the conversion factor. 1 atmosphere equals to 760 torrs. We start with our given of 1140 torrs and multiply by a fraction composed of both terms and the conversion factor arranged so that torrs will cancel and only atmospheres remain, for a total of 1.5 atmospheres. Now we substitute these values into the density formula we derived earlier. After performing the calculation, we get density equals to 6.39 grams per liter. Therefore, the correct answer is choice C.